NASA's James Webb Space Telescope JWST has recently confirmed a discovery that challenges traditional views on the origins and evolution of galaxies and supermassive black holes. An international team led by researchers from Penn State utilized JWST's NIRSpec instrument as part of the RUBIES survey to detect three mysterious objects in the early universe, dating to just 600 to 800 million years after the Big Bang, when the universe was only about 5% of its current age. The findings were published today, June 27th, in Astrophysical Journal Letters. The team examined the intensity of different wavelengths of light, or spectral measurements, emitted by these objects. Their analysis revealed traces of ancient stars, hundreds of millions of years old, existing in a much younger universe than previously thought possible. In a surprising twist, the researchers also discovered signs of enormous supermassive black holes within the same objects. These black holes are estimated to be 100 to 1,000 times larger than the supermassive black hole in the Milky Way. Current models of galaxy growth and supermassive black hole formation, which expect galaxies and their black holes to grow together over billions of years, did not predict such findings. We confirmed that these objects, in an only 600 to 800 million year old universe, appear to be filled with stars that are hundreds of millions of years old. Remarkably, these objects record some of the earliest signatures of ancient starlight, said Bingji Wang, a postdoctoral researcher at Penn State and lead author of the paper. Finding ancient stars in a very young universe was entirely unexpected. Standard cosmology and galaxy formation models, while highly successful, do not fully accommodate these bright objects. The team first noticed the massive objects in July 2020 to when JWST released its initial dataset. They published a paper in Nature a few months later, announcing the existence of these objects. At the time, researchers suspected the objects were galaxies, but continued their analysis by obtaining spectra to better understand the objects' actual distances and the sources of their immense light. With new data, the team painted a clearer picture of what these galaxies looked like and what they contained. They confirmed that the objects were indeed galaxies close to the dawn of time and also found evidence of surprisingly large supermassive black holes and an unexpectedly ancient star population. "This is very perplexing," said Joel Leyer, assistant professor of astronomy and astrophysics at Penn State and co-author of both papers. "You can fit this into our current universe model, but it requires making some exotic, crazy adjustments for rapid formation at the beginning of time. This is, without doubt, the strangest and most interesting set of objects I've seen in my career." JWST is equipped with infrared detection instruments capable of detecting light emitted by the oldest stars and galaxies. According to Leyer, the telescope essentially allows scientists to look back in time, close to the beginning of the universe as we know it. One challenge in analyzing ancient light is differentiating between the types of objects emitting it. These early objects exhibit features characteristic of both supermassive black holes and ancient stars. Aside from their unexplained masses and ages, if some of the light indeed comes from supermassive black holes, then these are not typical supermassive black holes. They produce far more ultraviolet photons than expected, and similar objects studied with other instruments lack the characteristic traces of supermassive black holes, such as hot dust and bright X-ray emissions. Perhaps most surprising is their apparent size. This groundbreaking discovery highlights the potential of JWST to revolutionize our understanding of the early universe and the formation and evolution of its structures.